In this video, I will explain how to derive an indirect utility function. So let's start with a couple quick definitions. A utility function tells us the utility a consumer gets from consuming specific quantities of goods X and Y. But an indirect utility function tells us the max utility a consumer can get based on their income and the price of goods X and good Y. So with a utility function, we get to directly know the utility based on the quantities consumed of goods X and Y. But in indirect utility, it still tells us something about the utility, but it does so based on income and the price of goods X and Y. So let's consider the following example. Let's say that a consumer has the following utility function. U is equal to X to the 1/2 times Y to the 1/2. We know the consumer also has the following budget constraint equation. M, their income, is equal to the price of X times the quantity of X plus the price of Y times the quantity of Y. We are asked to find V, which represents the indirect utility function. So let's find this indirect utility function if we're given this utility function. So the first step to figuring this out is recognizing that a consumer is able to maximize their utility when the marginal utility of X divided by the price of X is equal to the marginal utility of Y divided by the price of Y. So we're going to start by first finding the marginal utility of X and the marginal utility of Y. So the marginal utility of X, that's going to be the derivative of the utility function with respect to X. So the derivative of this function with respect to X would be 1/2 times X to the negative 1/2 times Y to the 1/2. And similarly, we can find the marginal utility of Y. That's going to be the derivative of the utility function with respect to Y. So the derivative of this function with respect to Y is going to be 1/2 times X to the 1/2 times Y to the negative 1/2. So now that we found these two quantities, we'll plug it into this equation right here. So let's go ahead and do that. So we'll get 1/2 X to the negative 1/2 times Y to the 1/2 divided by the price of X is equal to, for the marginal utility of Y, we found that to be 1/2 times X to the 1/2 times Y to the negative 1/2 over the price of Y. Now let's rewrite this equation to make it a little easier to read. So let's move our negative exponents to the denominators to make them positive. And we'll write our 1/2 by moving the 2 to the denominator as well. So we can rewrite this as Y to the 1/2 over 2 times X to the 1/2 times the price of X. So see, we just moved the X to the negative 1/2 to the denominator to give it a positive exponent. And similarly, on the right-hand side, we can write this as X to the 1/2 over 2 times Y to the 1/2 times the price of Y. So now that we've written this equation, what we're going to do is solve for both X and Y. So I'm going to clear a little bit of space here. Okay, so here's the equation we left off with. We said we want to solve for X and Y. So let's cross multiply and set these values equal to each other. So when we do that, we get 2 times the price of Y times Y. So when we multiply this Y to the 1/2 times this Y to the 1/2, we just get Y to the first power right here. And that will be equal to 2 times the price of X times X. So we want to solve for X and Y. So we'll notice that these 2's cancel out on both sides. And we can easily see that Y is equal to the price of X times X divided by the price of Y. And similarly, X is going to be equal to the price of Y times Y divided by the price of X. Now what we're going to do is take these values for X and Y and plug them into the budget constraint equation. So let's plug in this quantity for X. So we'll say M, income, is equal to the price of X times the price of Y times Y over the price of X. And then we have plus the price of Y times Y. So we'll notice that this price of X will cancel out with this price of X, and we'll have M is equal to, so here we just have the price of Y times Y, and then we have another price of Y times Y. So that's 2 price of Y times Y's. So we'll say M is equal to 2 times the price of Y times Y. So notice that we can solve for Y by simply dividing both sides by 2 times the price of Y. So we'll find that Y is equal to M divided by 2 times the price of Y. Now we can repeat this process and plug in this value of Y into the budget constraint, and we'll be able to solve for X. So we'll get M is equal to the price of X times X plus the price of Y times remember we're plugging in this value for y. So we have the price of x times x divided by the price of y. So we'll notice that these price of y's will cancel out, and here we have the price of x times x plus the price of x times x, so that's two of those quantities. So we have m is equal to 2 times the price of x times x. So to solve for x, we can divide both sides by 2 times the price of x, and we'll find that x is equal to m divided by 2 times the price of x. Now notice what we've done. We've written x in terms of income and the price of x, and we've written y in terms of the income and the price of y. So the very last step to writing this indirect utility function is to plug these values of x and y into the original utility function right here. So let's clear a little bit of space and write that. So we can say that v, our indirect utility function, is equal to, let's take this value of x and plug it into the utility function. So we'll have m divided by 2 times the price of x to the 1/2. And then we're taking this quantity for y and we're plugging it in for y right here in the utility function. So we have m divided by 2 times the price of y to the 1/2. So this is our final answer, and it tells us the max utility that a consumer can get based on their income, m, and the price of the goods, p of x and p of y. So that's the general process you can use to find an indirect utility function when you are given a utility function.